Today I'm going to be sharing the fourth chapter of the Oqtane module development series related to repositories and models. Before I go any further, I just wanted to mention that if you want to find out any information related to the Oqtane community, you can go to oqtane.org. And if you would like to access the source code for the Oqtane framework, you can do that on github/octane/octane.framework. And if you want to access any of the code related to the example module project that I've been covering as part of this tutorial, you can also find that at github.com/octane/dnf.projects. And with that, we're going to go straight into looking at how Oqtane deals with repositories and models. All right, so we're going to head into Visual Studio. All right, so the first thing we're going to do is we're going to look at the dnf.projects project. If we go into the server project, we can see that there's a repository folder that's been created for us and a scripts folder. I'm going to focus on the repository folder first. First file I'm going to take a look at here is project context. So by default, Oqtane uses entity framework for establishing access to its databases behind the scenes. And there's some important aspects to keep in mind when Oqtane is dealing with data. First of all, we've already covered this in the last section, but we have to decorate the project context class with iService. This is to allow it to be auto-registered during startup of Oqtane. And then we also have a DBContext base. And DBContext base is really important when you're building out your repositories as part of Oqtane. And we can see that we're inheriting from DBContext base. We have a couple of different objects that we're managing through entity framework. One is a project object, one's a project activity object. And then we have a constructor with very specific signature. And you absolutely do need to use this signature because this basically handles multi-tenant database connections, which are, the whole, one of the big benefits of Oqtane is that it is multi-tenant capable. And let me explain a little bit more about DBContext base. So I'm going to switch over to Oqtane for a moment, and we're going to look at DBContext base. So how does DBContext base work? Well, it basically uses the information that's passed on the URL to the controller APIs. And it's using IHTTP context accessor to access information that is part of the URL. And so basically what it does is it basically uses this tenant resolver.getTenant to figure out which tenant the request is for. So if we go look at tenant resolver also uses IHTTP context accessor. And typically, the alias information is being passed on the URL. And so it will get the alias ID from the request that was passed to the controller method. And then it will do a very quick lookup against all of the alias that have been defined in the installation. And from that, it'll be able to figure out which tenant. And that's important because the tenant is what defines the database. So, and going back to like an earlier session, we talked about the fact that Oqtane supports multiple databases. So even though in the app-settings.config file, there's a connection string which points to a database, that's not the only database that Oqtane is dealing with. So if you're taking advantage of the multi-database capability, the database is actually defined within each tenant. So it's very important that you build your repositories in this manner. So again, you've got DBContext base, which uses tenant resolver, which uses the URL to get the tenant. And then from there, it figures out, it basically builds out your, it gets the connection string from the tenant, and then basically connects to SQL Server, and then gets access to the underlying data. So going back to the DNF projects project, we can see how DBContext base is used as part of the project context to get access to the right database. Again, we're using proper sort of structure for our services. so that we can use them in dependency injection. We have an I project repository, which defines all of the different methods that we're going to need when we're calling our repository. And then we actually have an implementation of I project repository, which is project repository, which uses the project context, which we already talked about, which obviously uses entity framework under the covers. And it's using standard simple entity framework type of methods to both do lookups, to do add, to do updates, to do deletes. So pretty simple data access. The trick is to make sure that you set up the context properly using DBContext base. And again, we're using iService as a decorator interface again, because we want our repository methods to be registered in dependency injection so that we can use them elsewhere. So I think that that covers the repository aspect of things. So now, basically, how does our module objects actually get created in the database? By default, Oqtane uses scripts to do that. It's basically generated a couple of scripts in a scripts folder automatically for us. So it's got an installation script, which is very typical type of transact SQL type of commands using a create table kind of a command with all of the different columns. In this particular case, it's creating a couple of tables, and then it's generating the foreign key relationships between them. So this, the other thing to notice is that if we highlight this file, we can look at the build action, and it's flagged as an embedded resource. This is really important, that your SQL scripts are flagged as embedded resources. This is so that they are compiled into the DLL. Because you do not deploy these scripts as a separate asset during deployment. They need to be part of the DLL so that Oqtane is able to find them and execute them on startup. There's also an uninstall script file that's created, and this uninstall script, all it does is basically drop the two tables that are created during installation. And this is just to do some cleanup. And so it's just a good idea to have both an install and an uninstall script. And again, the uninstall script is an embedded resource so that it's compiled into the DLL for you. So that's how the scripts work. And again, having to flag them as embedded resources. There's also a naming convention which is used for scripts. In general, we try to use the name of the project, and then the version number that the script is associated to, and then .sql to designate that it's an actual SQL script file. Another thing, so we've sort of covered the repository side of things. Now, what about the models themselves? So if I look in the DNF projects.shared project, we will have a models folder. So if we looked at the project model, we can see that it defines the different properties that should correspond to the columns that are part of our table in our database. In this case, we have a model that's called project, but the actual database table is called DNF project. And it's called DNF project so that it doesn't clash with any other objects that are in the database. And so, but because of that, we have to define the relationship between the model and the underlying table. We're also using something called iAuditable in this case. So iAuditable is a convenient interface that you can use to basically set the audit fields. So these fields created by, created on, modified by, modified on. They have to be part of my model in order for this to work. And then you implement the iAuditable interface. And if we shift back over into Oqtane, we can see that it's actually using the iAuditable interface during the save changes. So if you're doing an add or an update operation, it will automatically determine which user is interacting with the application at that point in time. And here we go. It's checking to see if the entity implements iAuditable. And if it is, if those properties also exist, created by, created on, modified, modified on, and it fills in the property values automatically for you. There's also an iDeletable as well, which does something similar. But basically, this saves you the effort of having to do audit tracking in each of your own repository classes, and it's taken care of centrally as part of the DBContext. And this is a powerful feature of EF Core. And if we go back to our model project, these are all of the properties which correspond to columns in our database table. And sometimes we want to have additional properties as well, which are there for convenience sake, but don't necessarily map to columns that are in the database. So I have a lot of not mapped columns, or sorry, properties as well, where I'm keeping track of additional pieces of information, which EF Core is going to ignore because they don't need to be synchronized between the model and the database table. And so that's the purpose of the not mapped capability. And I think that that's all we wanted to cover when it came to repositories and models. And next we're going to cover the managers and module interface capabilities.